Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video, and today we're going to do this mechanism right here. So let's get into it. All right, here we have an interesting reaction. Something's going on here. What's this? Now we have a 4-member ring and a 6-member ring, but over here we have a 6 and a 5. This is a spiral cycle, and this is a fused bicyclic. Something's going on. Something weird's happening here, isn't it? Well, let's just do what we know is right. We know this is an SN1 reaction. We know that to be true. How do we know that? Well, we have secondary halide and methanol and heat. So we know it's an SN1 reaction. So let's go ahead and just draw that. So we know that the leaving group here is going to leave. We know that to be true. And that's going to give us the carbocation that we all know is going to form, because it's SN1. There we go. So there's my secondary carbocation. But now, let me draw this just a little bit bigger. I want you guys to be able to really see this. I'm just going to draw a little bigger. I'm going to draw the same thing, just bigger. There we go. So now, same thing, just bigger. There's a carbocation on the secondary carbon. Now, another thing that can cause rearrangement, is ring strain. So we're going to rearrange from here to here, and the driving force is ring strain. Also, we're going to go from a secondary to a tertiary carbocation. So let's just do that. So here, this bond will migrate to here, or rearrange to there. Now, remember, molecules aren't thinking, they're just reacting. Okay? So this pair of electrons in this bond migrates over to here. Now remember, these sigma bonds that are adjacent to the carbocation are hyperconjugating. Right, very good, they're hyperconjugating. So they're hyperconjugating to this cation, so they're going to slide on over because they're already interacting. As this bond interacts more and more with this carbocation, the positive charge builds up here. That's a tertiary carbon. That's more stable than secondary. Also, we're throwing out some ring strain. We're getting rid of some 4-member ring strain. That's a good thing. Okay? So we're going to get now, at the end of all this, a rearranged carbocation. Okay, so that's going to put the plus charge here. If you don't see it, let me number the carbons for you. So let's call this carbon 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Where carbon 4 now bonds to 5. So if you can't see it, that's how it works. Now, solvent will now come in. Attack there, just like before, like a regular SN1 reaction. Now more solvent will come and deprotonate the alcohol, or the protonated ether, excuse me. And that's going to give us, at the end of the day, the product. And there you go. Now, guys, I hope you found this video helpful. If you did, well, before I do all that, let's talk a little bit about what's going on here. So this is just an SN1 reaction with a rearrangement. The rearrangement happened to be a ring expansion. It's just a rearrangement, guys. All right, so that's the end of this video. I hope you found it helpful. If you did, slap that like button. Go ahead and leave a comment down below. Let me know what kind of job I'm doing. If you're happy with the work, please let me know. Also, I wanted to thank you guys for viewing. Please subscribe to my channel. And with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.